An equinox occurs twice a year, around March 20 and September 22. The word itself has several related definitions. The oldest meaning is the day when daytime and night are of approximately equal duration. The word equinox comes from this definition, derived from the Latin aequus and nox. The equinox is not exactly the same as the day when period of daytime and night are of equal length for two reasons. Firstly, sunrise, which begins daytime, occurs when the top of the sun's disk rises above the eastern horizon. At that instant, the disk's center is still below the horizon. Secondly, Earth's atmosphere refracts sunlight. As a result, an observer sees daylight before the first glimpse of the sun's disk above the horizon. To avoid this ambiguity, the word equilux is sometimes used to mean a day on which the periods of daylight and night are equal. Times of sunset and sunrise vary with an observer's location, so the dates when day and night are of exactly equal length likewise depend on location. The other definitions are based on several related simultaneous astronomical events, and refer either to the events themselves or to the days on which they occur. These events are the reason that the period of daytime and night are approximately equal on the day of an equinox. An equinox occurs when the plane of Earth's equator passes the center of the Sun. At that instant, the tilt of Earth's axis neither inclines away from nor towards the Sun. The two annual equinoxes are the only times when the subsolar point the place on Earth's surface where the center of the Sun is exactly overhead is on the equator, and, conversely, the Sun is at zenith over the equator. The subsolar point crosses the equator, moving northward at the March equinox and southward at the September equinox. At an equinox, the Sun is at one of the two opposite points on the celestial sphere where the celestial equator and ecliptic intersect. These points of intersection are called equinoctial points, classically, the vernal point and the autumnal point. The equinoxes are the only times when the solar terminator is perpendicular to the equator. As a result, the northern and southern hemispheres are illuminated equally. Equinoxes on the Earth. Date: when Julius Caesar established his calendar in 45 BC, he set March 25 as the spring equinox. Because a Julian year is slightly longer than an actual year, the calendar drifted with respect to the equinox, such that the equinox was occurring on about March 21 in AD 300 and by AD 1500 it had reached March 11. This drift induced Pope Gregory XIII to create a modern Gregorian calendar. The Pope wanted to restore the edicts concerning the date of Easter of the Council of Nicaea of AD 325 equinox. So the shift in the date of the equinox that occurred between the 4th and the 16th centuries was annulled with the Gregorian calendar, but nothing was done for the first 4 centuries of the Julian calendar. The days of February 29 of the years AD 100, AD 200, AD 300, and the day created by the irregular application of leap years between the assassination of Caesar and the decree of Augustus rearranging the calendar in AD 8, remained in effect. This moved the equinox 4 days earlier than in Caesar's time. Names: vernal equinox and autumnal equinox. These classical names are direct derivatives of Latin. These names are based on the seasons, and can be ambiguous since seasons of the northern hemisphere and southern hemisphere are opposites, and the vernal equinox of one hemisphere is the autumnal equinox of the other. Spring equinox and fall equinox or autumn equinox. These are more colloquial names based on the seasons, and are also therefore ambiguous across hemispheres. March equinox and September equinox, names referring to the times of the year when such equinoxes occur. These are without the ambiguity as to which hemisphere is the context, but are still not universal as not all people use a solar-based calendar where the equinoxes occur every year in the same month, and the names are not useful for other planets, even though these planets do have seasons. Northward equinox and southward equinox, names referring to the apparent motion of the Sun at the times of the equinox. The least culturally biased terms. Vernal point and autumnal point are the points on the celestial sphere where the Sun is located on the vernal equinox and autumnal equinox respectively. Usually this terminology is fixed for the northern hemisphere. First point of Aries and first point of Libra are names formerly used by astronomers and now used by navigators and astrologers. Navigational ephemeris tables record the geographic position of the first point of Aries as the reference for position of navigational stars. Due to the precession of the equinoxes, the astrological signs of the tropical zodiac where these equinoxes are located no longer correspond with the actual constellations once ascribed to them. The equinoxes are currently in the constellations of Pisces and Virgo. In sidereal astrology, by contrast, the first point of Aries remains aligned with Ras Hamel, the head of the Ram, that is the Aries constellation. Length of equinoctial day and night. On the day of the equinox, the center of the Sun spends a roughly equal amount of time above and below the horizon at every location on the Earth, so night and day are about the same length. The word equinox derives from the Latin words aequus and nox. In reality, the day is longer than the night at an equinox. Day is usually defined as the period when sunlight reaches the ground in the absence of local obstacles. From the Earth, the Sun appears as a disk rather than a point of light, so when the center of the Sun is below the horizon, its upper edge is visible. Furthermore, the atmosphere refracts light, so even when the upper limb of the Sun is 0.4 degrees below the horizon, its rays curve over the horizon to the ground. In sunrise-sunset tables, the assumed semidiameter of the Sun is 16 minutes of arc and the atmospheric refraction is assumed to be 34 minutes of arc. Their combination means that when the upper limb of Sun is on the visible horizon, its center is 50 minutes of arc below the geometric horizon, which is the intersection with the celestial sphere of a horizontal plane through the eye of the observer. These effects make the day about 14 minutes longer than the night at the equator and longer still towards the poles. The real equality of day and night only happens in places far enough from the equator to have a seasonal difference in day length of at least 7 minutes, actually occurring a few days towards the winter side of each equinox. Because the Sun is a spherical source of light, the actual crossing of the Sun over the equator takes approximately 33 hours. At the equinoxes, the rate of change for the length of daylight and nighttime is the greatest. At the poles, the equinox marks the start of the transition from 24 hours of nighttime to 24 hours of daylight. Far north of the Arctic Circle, at Longyearbyen, Svalbard, Norway, there is an additional 15 minutes more daylight every day about the time of the spring equinox, whereas in Singapore, the amount of daylight in each daytime varies by just a few seconds. Geocentric view of the astronomical seasons. In the half-year centered on the June solstice, the Sun rises north of east and sets north of west, which means longer days with shorter nights for the northern hemisphere and shorter days with longer nights for the southern hemisphere. In the half-year centered on the December solstice, the Sun rises south of east and sets south of west and the durations of day and night are reversed. Also on the day of an equinox, the Sun rises everywhere on Earth at about 0600 and sets at about 1800. These times are not exact for several reasons. The Sun is much larger in diameter than the Earth, so that more than half of the Earth could be in sunlight at any one time. Most places on Earth use a time zone which differs from the local solar time by minutes or even hours. For example, if the Sun rises at 7 o'clock on the equinox, it will set 12 hours later at 19 o'clock. Even people whose time zone is equal to local solar time will not see sunrise and sunset at 6 o'clock and 1800. This is due to the variable speed of the Earth in its orbit, and is described as the equation of time. It has different values for the March and September equinoxes. Sunrise and sunset are commonly defined for the upper limb of the solar disk, rather than its center. The upper limb is already up for at least a minute before the center appears, and the upper limb likewise sets later than the center of the solar disk. Also, when the Sun is near the horizon, atmospheric refraction shifts its apparent position above its true position by a little more than its own diameter. This makes sunrise more than 2 minutes earlier and sunset an equal amount later. These two effects combine to make the equinox day 12 7 min long and the night only 11 53 min. Note, however, that these numbers are only true for the tropics. For moderate latitudes, the discrepancy increases. And closer to the poles it becomes very much larger. Up to about 100 km from either pole, the Sun is up for a full 24 hours on an equinox day. Night includes twilight. If dawn and dusk are instead considered daytime, the day would be almost 13 hours near the equator, and longer at higher latitudes. Height of the horizon changes the day's length. For an observer atop a mountain, the day is longer, while standing in a valley will shorten the day. Day arcs of the Sun. Some of the statements above can be made clearer by picturing the day arc. The pictures show this for every hour on equinox day. In addition, some ghost suns are also indicated below the horizon, up to 18 degree below it. The Sun in such areas still causes twilight. The depictions presented below can be used for both the northern hemisphere and the southern hemisphere. The observer is understood to be sitting near the tree on the island depicted in the middle of the ocean. The green arrows give cardinal directions. In the northern hemisphere, north is to the left, the Sun rises in the east, culminates in the south, while moving to the right and setting in the west. In the southern hemisphere, south is to the left, the Sun rises in the east, culminates in the north, while moving to the left and setting in the west. The following special cases are depicted. Celestial coordinate systems. The vernal equinox occurs in March, about when the Sun crosses the celestial equator south to north. The term vernal point is used for the time of this occurrence and for the direction in space where the Sun is seen at the time, which is the origin of some celestial coordinate systems. In the ecliptic coordinate system, the vernal point is the origin of the ecliptic longitude. In the equatorial coordinate system, the vernal point is the origin of the right ascension. Because of the precession of the Earth's axis, the position of the vernal point on the celestial sphere changes over time, and the equatorial and the ecliptic coordinate systems change accordingly. Thus, when specifying celestial coordinates for an object, one has to specify at what time the vernal point and the celestial equator are taken. That reference time is called the equinox of date. The autumnal equinox is at ecliptic longitude 180 degree and at right ascension 12 hours. The upper culmination of the vernal point is considered the start of the sidereal day for the observer. The hour angle of the vernal point is, by definition, the observer's sidereal time. The same is true in Western tropical astrology. The vernal equinox is the first point of the sign of Aries. In this system, it is of no significance that the equinoxes shift over time with respect to the fixed stars. Using the current official IAU constellation boundaries and taking into account the variable precession speed and the rotation of the ecliptic the equinoxes shift through the constellations as follows. The March equinox passed from Taurus into Aries in year 1865, passed into Pisces in year 67, will pass into Aquarius in year 2597, will pass into Capricornus in year 4312. It passed along a corner of settlers on 0 degree 10 distance in year 1489. The September equinox passed from Libra into Virgo in year 729, will pass into Leo in year 2439. Cultural aspects. A number of traditional spring and autumn festivals are celebrated on the date of the equinoxes. Equinoxes of other planets. Equinox is a phenomenon that can occur on any planet with a significant tilt to its rotational axis. Most dramatic of these is Saturn, where the equinox places its normally majestic ring system edge-on facing the Sun. As a result, they are visible only as a thin line when seen from Earth. When seen from above, a view seen by humans during an equinox for the first time from the Cassini space probe in 2009, they receive very little sunshine, indeed more planet shine than light from the Sun. This lack of sunshine occurs once every 14.7 years. It can last a few weeks before and after the exact equinox. The most recent exact equinox for Saturn was on August 11, 2009. Its next equinox will take place on April 30, 2024. One effect of equinoctial periods is the temporary disruption of communication satellites. For all geostationary satellites, there are a few days around the equinox when the Sun goes directly behind the satellite relative to Earth for a short period each day. The Sun's immense power and broad radiation spectrum overload the Earth station's reception circuits with noise and, depending on antenna size and other factors, temporarily disrupt or degrade the circuit. The duration of those effects varies but can range from a few minutes to an hour. See also, aphelion. Occurs around July 5, Lady Day, Nowruz, solstice, Songkran, sun outage. A phenomenon that occurs around the time of an equinox. Notes. References. External links, details about the length of day and night at the equinoxes. U.S. Naval Observatory. Naval Meteorology and Oceanography Command, calculation of length of day, equinoctial points. The Nuttall Encyclopedia, table of times for equinoxes, solstices, perihelion and aphelion in 2000. 2020, table of times of spring equinox for 1,000 years, 1452. 2547. Gray, Meehan. Merrifield, Michael. Solstice and Equinox. 60 Symbols. Brady Heron for the University of Nottingham. A.